Hi, hi. Good morning, students. I am Vaishakhi Shah from LJ Institute of Engineering and Technology. Now, in last lecture, we discussed different types of manometers, which are used to measure pressure or pressure difference between two pipes. Now, there are different devices which are used to measure pressure. Not only manometer, mechanical gauges are also used to measure the pressure. So here is the list of different pressure measuring devices. Very first device, which is manometers, and there are different types of manometer. We already studied. Very first manometer is a simple manometer, and second is a differential manometer. Now, in a simple manometer, there are subtypes like piezometer, U-tube manometer, and single column manometer. In differential manometer, again the subtypes are inverted U-tube manometer, U-tube differential manometer, and micro manometer. Now, in mechanical gauges are also the devices which are used to measure the pressure. Now, the different types of mechanical gauges are Burden tube pressure gauge, diaphragm a pressure gauge, and bellow pressure gauge. Now, mechanical gauges are not important as GTU point of view. So, we covered the manometers which are important as exam point of view. So, now in today's lecture we are going to study some examples based on the manometer. Okay. So, let us start. Our first example here is the data given to you is a right limb of a simple U-tube manometer containing mercury is open to the atmosphere, while the left limb is connected to a pipe in which a fluid of specific gravity 0.9 is flowing. The center of pipe is 12 centimeter below the level of mercury in the right limb. Find the pressure of fluid in pipe if difference of mercury level in two limb is 20 centimeter. Now, here the manometer which is given to you is a simple U-tube manometer. In simple U-tube manometer, there is a mercury which is filled at a U shape. Okay, one end is open to atmosphere and the other end is connected to pipeline. Here that is a pipe A indicated in the diagram. Okay. So, now here this height is 20 centimeter. So, the difference of mercury level is 20 centimeter indicated in this diagram. Now, this is your baseline which is AA. Now, the distance, the center of pipe is 12 centimeter below the level of mercury. So, it indicates the distance which is 12 centimeter below the level of mercury. Now, the data given to you is the fluid which is filled in pipe has specific gravity 0.9. So, as we know that density, if we have to find out density of that fluid, then density equals to specific gravity into 1000. Specific gravity into 1000. So, here density of that fluid which is filled in pipe, that is rho 1, and rho 1 equals to S1 into 1000. S1 is 0.9. So, 0.9 into 1000, that is 900 kg per meter cube. Now, second, the specific gravity of mercury, as we know the specific gravity of mercury is 13.6. So, here density of mercury, that is rho 2. Okay. So, density of mercury is specific gravity into 1000, 13.6 into 1000, that is 13,600 kg per meter cube. Now, here as per your diagram, difference of mercury level in two limbs, that is H2. Okay. So, here H2, that is 20 centimeter given to you. The first thing in this example is that you have to draw the diagram first. Very firstly, you have to draw the diagram, then after you can solve the example. Okay. So, here H2 is 20 centimeter which is 0.2 meter. Now, as per the diagram, here this height H1, if I have to find out this H1 height, then H1 equals to 20 minus 12, which is 8 centimeter, so which is 0.08 meter. Okay, so now solving this example here, this is your diagram. Now pressure on left side equals to pressure on right side. Be clear that in any example of manometer, the common procedure of solve the example is, first you have to take pressure on left side of limb, second you have to take pressure on right side of limb, and left side pressure equals to right side pressure, equate both the pressure. This is the common method for solving examples of manometer. So here first pressure on left side, that is PA, pressure due to pipe A. Second pressure is rho 1 G H1 equals to rho 2 G H2. Okay. Now as we know the values here, PA is your unknown, we have to find out PA here. So PA equals to rho 1, that is 900, G, that is 9.81, and H1, that is 0.08 as per the diagram, equals to rho 2, that is 13,600, which is 13.6 into 1000 into G 9.81 into 0.2, that is your H2. Now solving the values in calculator, you get final answer for PA, that is 2.597 Newton per centimeter square. This is your final answer for pressure at point A. Okay, in simple YouTube manometer. Okay, now the next example here is a differential YouTube mercury manometer is used to measure the difference of pressure between two water pipes A and B. Find the pressure at A if level difference in mercury in manometer is 150 mm as shown in figure. The pressure at B is 300 kilopascals. Now in this data, the diagram is already given to you. This is your diagram of manometer. Now in this manometer, there are two pipes, pipe A and pipe B. Both pipes are at different level. So this is the case of differential YouTube manometer. Now in the data, the difference between pipe A and B is 200 mm, which is given to you, and height from A to XX axis, which is 450 mm, and rise of mercury is 150 mm. That things given to you already in data. Now we have to find out pressure in pipe A. So here PA is your unknown. This is your pipe A, this is your pipe B, and this is the rise of mercury, which is 150 mm. Now in this data, the fluid in pipe A having specific gravity 0.9 and fluid in pipe B with specific gravity 0.8. Now by using specific gravity, how can you find out density? What is the equation? Yes, so the fluid in pipe A having density 900 kg per meter cube. Simply multiply specific gravity into 1000. So 900 kg per meter cube is the density of fluid in pipe A, and density of fluid in pipe B is 800 kg per meter cube. Okay. Now we have to solve the example. So there is the common method where first we have to find out pressure in left column, second we have to find out pressure in right column, and after that equate the condition. So here this is your diagram. Now first pressure in left column above line XX equals to pressure in right column above XX. So first, what is the pressure in left column? Okay, so first is pressure due to pipe A, which is PA plus rho 1 G H1. Here rho density, that is 900, G, that is 9.81, and height, which is 0.45, equals to Now on the right hand side, first pressure is PB. So PB plus rho 2 GH2, that rho 2 is for mercury, which is 13,600 into 9.81 into 0.15. Now the third pressure due to fluid in pipe B, which is this, which fluid with density 800. So here rho 3 GH3, that is rho which is 800, G that is 9.81, and height that is 0.45 plus 0.2 minus 0.15, that is the height of fluid in pipe B. So by solving this equation in calculator, your final answer for pressure at A is 319.96 kilopascal or 3.199 into 10 raised to 5 Newton per meter square. Okay. So now next example, moving forward to our next example. Here in this data, a YouTube manometer is given to you connecting two pressure pipes. There are two pipes, pipe A and pipe B. Pipe A contains a liquid of specific gravity 1.5 under a pressure of 100 kilonewton per meter square. Pipe B contains oil of specific gravity 0.8 under a pressure 175 kilonewton per meter square. The point A is 3 meter above the point B. Height of liquid in left column 4 meter below point A. Now calculate the difference in mercury level in differential manometer. Now in this data, diagram is not given to you. You have to draw the diagram first. So here there are two pipes given to you. Now how can you decide that the both pipes are at same level or at different level? How can you decide that? So here pressures in the pipe given to you. Pressure in pipe A is 100 kilonewton per meter square and pressure in pipe B is 175 kilonewton per meter square. Now there are two different pressures. So the liquid rises opposite to the higher pressure point. So here pressure in pipe B is higher. So mercury rises opposite to that in pipe A. Remember that the liquid always rises opposite side of the higher pressure pipe. If pressure in pipe A is higher, then liquid rises in pipe B. So by this you can decide that both the pipes are at same level or not, and where up to which height level of mercury rises in which column, left side or right side. Okay. So here in this diagram there is a point A and point B, both are at a different level. Point B is 4 meter below than point A. Okay. This is given to you. Okay. Now point A is 3 meter above point B. Now pressure at point A is 100 kilonewton per meter square. So specific gravity of liquid is 1.5. So what is the density? 1500 kg per meter cube. Now pressure at point B is 175 kilonewton per meter square. So and the specific gravity of that liquid is 0.8. So density is 800 kg per meter cube. Okay. Now at U shape the mercury is filled. Mercury with specific gravity 13.6 and density 13,600. Okay. Now here we have to find out mercury level, difference of mercury level which is indicated as h here. Okay. So, there are 3 different distances, first is 3 meter, second is 4 meter and third is h. We have to find out value of h here. Okay. So, let us start here. Now, like here same pressure on left hand side equals to pressure in right hand side. So, here pressure in left hand side, that first pressure is PA plus rho 1 G H1, okay, plus rho 2 G H, rho 2 G H equals to right hand side, the pressure on right side, that is first pressure is PB, second is rho 3 into G, the third liquid in pipe B, rho 3 into G, and what is the height of the liquid in pipe B? You can say that it is 4, just see this diagram, in the diagram 4 minus 3 plus H, this height is 4 minus 3, so you get this height plus H, so that is your height on right hand side. Okay. Now, placing all the values here, PA, that is 100 into 10 raised to 3 plus rho 1, that is 1.5 into 1000 into 9.81 into 4 plus 13.6 into 1000 into 9.81 into H equals to 1.75 into 10 raised to 3 plus 0.8, that is specific gravity of fluid in pipe B. So, 0.8 into 1000 into 9.81 and 1 plus H, 4 minus 3, that is 1 plus H. So, by solving this equation in calculator, you get final answer for H, that is 0.191 meter, 0.191 meter. Okay. Okay. So, here small h, that is 0.191 meter. Now, our next example here, an inverted differential manometer. Firstly, the type of manometer given to you is inverted manometer. Okay. So, in inverted differential manometer, which is connected to 2 pipes A and B, which convey water. The fluid in manometer is oil. In manometer, in a U shape, the fluid filled is oil with specific gravity 0.8. For the manometer readings are shown in figure. The diagram is already given to you. Find the pressure difference between A and B. Here we have to find out pressure difference between 2 pipes. Okay. Here specific gravity of oil is 0.8. So, density is 0.8 into 1000, which is 800 kg per meter cube. Okay. Now, difference of oil in 2 column. What is the difference of oil layer in 2 column? So, see in the diagram, it is 30, 30 plus 20 minus 30. So, you get this distance, which is 20 centimeter, that is your difference of oil. Okay, this distance 30 plus 20 minus 30. Okay. Now, the same procedure, pressure in left column, that is first pressure is PA. Now, here we are taking minus sign. Remember that in other examples, we are taking positive sign, PA plus rho GH plus rho 2 GH, etc. But in inverted manometer, we are taking negative sign. So, PA minus rho is 1000 because water is flowing. So, 1000 into G, that is 9.81, and H, that is 0.3. So, that is PA minus 2943. Now, pressure in right column, that is PB minus first, due to liquid in pipe A, pipe B, which is water, that is 1000 into 9.81 into 0.3 minus 800 into 9.81, that is rho GH, H is 0.2. So, you get PB minus 4512.6. Now, pressure on left hand side equals to pressure on right hand side. So, PA equating both the equation, you get PB minus PA, that is 1569.6 Newton per meter square. So, here your answer must be with positive sign. So, you can't take PA minus PB. Here your answer is PB minus PA equals to 1569.6 Newton per meter square. Okay. So, today we solved some example based on differential different types of manometers. In next session, we are going to study some more topics in related to this subject. Okay. Goodbye.